Welcome to our presentation on the fascinating topic of gravitational field. From the tiniest particles to the largest celestial bodies, gravity is an ever-present force that shapes our universe in ways we are only beginning to understand. In this presentation, we will explore the mysteries of gravity and its profound impact on the world around us. From black holes to time dilation, we will delve into the cutting-edge science behind this fundamental force of nature. What is a gravitational field? A gravitational field is the area around an object where its gravitational force can be felt. This force is what pulls objects towards each other, like how the Earth's gravity keeps us on the ground. The strength of the gravitational field depends on the mass of the object and the distance from it. Imagine a sheet of fabric stretched out flat. You place a heavy object in the center, it will create a dip in the fabric. This is similar to how a massive object creates a curvature in spacetime, which is what causes the gravitational force. Other objects will then roll towards this dip, just like how planets orbit around the sun. This is the basic idea behind how a gravitational field works. Gravity and the universe. Gravity plays a fundamental role in shaping the universe as we know it. It is the force that governs the motion of celestial bodies, from the smallest asteroids to the largest galaxies. Without gravity, the universe would be a vastly different place, with no stars, planets, or other celestial bodies. One of the most profound effects of gravity is its ability to cause objects to orbit around one another. This can be seen in the relationship between the Earth and the Moon, as well as between the Sun and the planets of our solar system. Gravity also causes the formation of galaxies and other large structures in the universe, as well as the distribution of dark matter, which makes up the majority of the mass in the universe. The Earth, gravity, and the Earth. Gravity is a fundamental force that shapes our world in countless ways. One of its most noticeable effects is on the weight of objects on Earth. The mass of an object remains constant no matter where it is in the universe, but its weight can vary depending on the strength of the gravitational field it is in. On Earth, the closer an object is to the center of the planet, the stronger the gravitational force it experiences, and thus the greater its weight. This effect can be seen in everyday life, from the way objects fall when dropped to the way we move and interact with our environment. It also has important implications for fields like engineering and physics, where precise measurements of weight and gravity are necessary for accurate calculations. Understanding the relationship between gravity and weight is crucial for understanding the world around us. Gravity and the Moon's gravitational pull is responsible for many of the phenomena we observe on Earth. One of the most notable effects is the tides, which are caused by the gravitational force of the Moon pulling on the Earth's oceans. This results in a rise and fall of sea levels that occurs twice a day. The strength of the tides is influenced by the position of the Moon in its orbit around the Earth. In addition to the tides, the Moon's gravity also affects the Earth's rotation. As the Earth rotates, the Moon's gravity pulls on it, causing a slight wobble in the planet's axis. This phenomenon, known as precession, has a cycle of about 26,000 years and can have an impact on long-term climate patterns. Gravity and the Sun. The Sun is a massive ball of gas held together by the force of its own gravity. This gravitational force is what keeps the Sun's core hot and allows it to emit light and heat. Without gravity, the Sun would simply dissipate into space. The gravity of the Sun also has a profound effect on the rest of the solar system. It keeps all the planets in orbit around the Sun, dictating their speed and distance from the star. In fact, the Sun's gravity is so strong that it even affects the comets and asteroids that pass through the solar system, altering their trajectories and sometimes causing them to collide with planets. Gravity and black holes. Black holes are one of the most fascinating and mysterious objects in the universe. They are formed when a massive star collapses under its own gravity, creating a singularity, a point of infinite density where the laws of physics as we know them break down. The gravitational pull of a black hole is so strong that nothing, not even light, can escape it. This means that once something crosses the event horizon, the point of no return, it is lost forever. The study of black holes has led to many breakthroughs in our understanding of gravity and the nature of the universe. Einstein's theory of relativity. Albert Einstein's theory of relativity revolutionized our understanding of gravity. According to this theory, gravity is not a force between masses, but rather a curvature of space-time caused by the presence of mass and energy. In other words, objects with mass create a curvature in space-time that causes other objects to move towards them. One of the key predictions of Einstein's theory of relativity is that time passes more slowly in strong gravitational fields. So this phenomenon, known as time dilation, has been observed in experiments involving atomic clocks and is an important factor in GPS technology. Curved spacetime. According to Einstein's theory of relativity, gravity is not a force that pulls objects towards each other. Instead, it is the curvature of spacetime caused by massive objects such as planets and stars. This means that objects with mass are not just affected by gravity, they actually create it. Imagine placing a heavy ball on a trampoline. The ball will create a depression in the fabric, causing nearby objects to roll towards it. Similarly, massive objects like planets create a curvature in spacetime, which causes other objects to move towards them. This explains why planets orbit around stars and moons orbit around planets. Gravity and time dilation. One of the most fascinating aspects of gravity is its relationship with time. According to Einstein's theory of relativity, the closer an object is to a massive body, the slower time moves for that object. This phenomenon is known as time dilation and has been observed in various experiments, including those involving atomic clocks. The reason for this effect is that gravity warps spacetime, causing it to curve around massive objects. As a result, time appears to slow down for objects in strong gravitational fields. This effect has practical implications for things like GPS satellites, which have to take into account the difference in time between their position in space and the Earth's surface. The measurement of gravity. Gravity is a fundamental force that affects everything in the universe, from the smallest particles to the largest celestial bodies. Measuring this force accurately is crucial for understanding the universe and developing technologies that rely on gravity, such as space travel and satellite communication. One of the most common methods for measuring gravity is through the use of a gravitometer. This instrument measures the acceleration due to gravity at a specific location by detecting the changes in the position of a free-falling object over time. Another method involves using a pendulum, which oscillates at a frequency that is directly proportional to the local acceleration due to gravity. By measuring the period of the pendulum's swing, scientists can determine the strength of the gravitational field. The gravitational constant, denoted as g, is a fundamental constant of nature that defines the strength of the gravitational force between two objects. It is a key component in understanding the behavior of celestial bodies and the workings of the universe. The value of g is notoriously difficult to measure accurately, and its precise value has been a subject of debate among scientists for centuries. However, despite this uncertainty, the gravitational constant remains an essential tool for physicists and astronomers in their quest to unravel the mysteries of the cosmos. Gravitational waves. Gravitational waves are ripples in the fabric of spacetime caused by the acceleration of massive objects, such as black holes or neutron stars. These waves were predicted by Einstein's theory of relativity over a century ago, but it wasn't until 2015 that they were directly detected by the Laser Interferometer Gravitational Wave Observatory Observatory. The detection of gravitational waves has opened up a new window into the universe, allowing us to observe cosmic events that were previously invisible, such as the collision of two black holes. It also confirms Einstein's theory of relativity and provides a new tool for studying the properties of the universe. The study of gravitational waves is an exciting and rapidly evolving field, with many new discoveries expected in the coming years. Applications of gravitational field. One of the most exciting applications of knowledge about gravitational field is in space travel. Understanding how gravity works allows us to launch spacecraft into orbit and navigate them through the solar system. If without this knowledge, we wouldn't be able to explore the universe beyond our planet. Another practical application of gravitational field is in satellite communication. Satellites are used for everything from weather forecasting to GPS navigation, and they rely on precise calculations of gravitational forces to stay in orbit and transmit data back to Earth. The future of gravitational field research. The current state of research on gravitational field is incredibly exciting. With the recent detection of gravitational waves, scientists have opened up a whole new avenue of exploration. We are now able to observe and study events in the universe that were previously invisible to us. Looking to the future, there are many potential developments in gravitational field research. One area of focus is on improving our ability to detect gravitational waves, which could lead to even more groundbreaking discoveries. Another area of interest is exploring the relationship between gravity and quantum mechanics, which could help us better understand the fundamental nature of the universe. Gravity and science fiction. Science fiction has long been fascinated with the concept of gravity, exploring its potential as a means of propulsion and even as a weapon. From Arthur C. Clarke's 2001, A Space Odyssey to Christopher Nolan's Interstellar, gravity has played a central role in some of the most iconic science fiction stories of all. Gravity and philosophy. Gravity has been a topic of philosophical inquiry for centuries, with thinkers from Aristotle to Newton pondering its nature and implications. One of the key philosophical questions surrounding gravity is its relationship to time and space. Does gravity distort space and time, or do space and time shape gravity? This question has been at the center of debates in both physics and philosophy, and continues to be an area of active research today. Gravity and spirituality. Gravity has been a source of fascination for many spiritual and religious traditions throughout history. In Hinduism, gravity is seen as the force that holds the universe together, while in Buddhism it is viewed as a manifestation of the law of karma. In Christianity, gravity is often associated with the concept of divine providence, while in Islam it is seen as evidence of Allah's power and wisdom. Despite these varying interpretations, one common thread among many spiritual traditions is the belief that gravity reflects a deeper spiritual truth about the nature of the universe. Some even argue that gravity may be a physical manifestation of a higher spiritual reality beyond our understanding. Gravity and the human experience. Gravity is an ever-present force in our lives, shaping our experiences of the world and our understanding of the universe. From the way objects fall to the ground to the tides of the ocean, gravity influences everything around us. But it's not just the physical effects of gravity that shape our experience. It also plays a role in our cultural and philosophical understandings of the world. For centuries, artists and thinkers have been inspired by the beauty and mystery of gravity, from the ancient Greeks to modern science fiction. Gravity has captured our imagination and sparked our curiosity about the nature of the universe. Whether we are contemplating the vastness of space or simply walking down the street, gravity is a constant reminder of our place in the world and our connection to the cosmos. The beauty of gravity. Gravity is often thought of as a force that holds us down to the earth, but it has a much more profound and beautiful role in the universe. From the graceful dance of planets around their stars to the swirling galaxies that make up our universe, gravity is responsible for creating some of the most stunning sights in the cosmos. One of the most striking examples of the beauty of gravity is the phenomenon of gravitational lensing. This occurs when the gravity of a massive object, such as a galaxy or a black hole, bends the path of light passing near it. The result is a distorted and magnified image of the object behind it, creating a breathtaking cosmic spectacle. Challenges in understanding gravity. Despite centuries of study, gravity remains one of the most mysterious and difficult forces to understand. One of the biggest challenges in understanding gravity is that it does not fit neatly into our current understanding of physics. While we have a good grasp of how other fundamental forces, such as electromagnetism and the strong and weak nuclear forces, work, gravity remains elusive. Another challenge in understanding gravity is that it is incredibly weak compared to the other fundamental forces. This makes it difficult to measure and study, as its effects are often overwhelmed by other forces. Additionally, gravity behaves differently on different scales, from the subatomic to the cosmic, making it a complex and multifaceted force to study. In conclusion, we have explored the fascinating world of gravitational field and its impact on the universe. We started by defining what a gravitational field is and how it works, then delved into its effects on celestial bodies such as the Earth, Moon, and Sun. We also discussed Einstein's theory of relativity and its relationship to gravity, as well as the measurement of gravity and recent discoveries such as gravitational waves. We examined the practical applications of knowledge about gravitational field in space travel and satellite communication, as well as its influence on popular culture, art, philosophy, and spirituality. Finally, we appreciated the aesthetic qualities of gravity and its role in shaping our experience of the world. As we continue to research and understand the complexities of gravitational field, we are reminded of the beauty and mystery of the universe. The study of gravity challenges us to expand our minds and imaginations and to appreciate the interconnectedness of all things. Let us continue to explore and appreciate the wonders of the cosmos and to strive for a deeper understanding of the forces that shape our existence. Carol, Sean M. Spacetime and Geometry. An Introduction to General Relativity, Cambridge University Press, 2003.2. Hawking, Stephen W. A Brief History of Time. Bantam Books, 1988. Thank you for watching. Don't forget to subscribe and turn on the notification bell to stay updated with our latest content. If you enjoyed this video, please give it a thumbs up and consider sharing it with your friends. We love hearing from you. Leave a comment below and let us know your thoughts or suggestions for future videos. New videos are coming soon. Stay tuned and keep an eye out for our next upload. Remember to hit that subscribe button so you don't miss out.